Hi, good afternoon. My name is David Garraway. I am a student at the City College of New York, Rowe School of Engineering. I am a part of the Advanced Mechatronics class there. Today we'll be talking about exoskeleton modeling. So hopefully I can give you all some insight on what I've learned. Um, so there are a few components that are absolutely important when when, when we're discussing soft robotics. That's back drivability, bandwidth, and weight. So essentially, we want the system to be highly backdrivable, have high bandwidth, and also be lightweight. Some of the advantages of a system being backdrivable are that it can operate in the reverse direction. When backdrivability is high, there's low resistive force acting. The system becomes less complex. Um, there's reduced friction and also lower inertia. Here we can see the transfer function of backdrivability, and you'll see where it's put to use a little bit later on. Now we have bandwidth. So bandwidth is basically, how quickly a system responds to changes in parameters that you want to control. In robotics, it's typically at a frequency at which the closed loop amplitude response reaches 3 decibels. Higher bandwidth generally provides stiffer motor performance and decreases error and improves transient response time. And here again, now we have the transfer function for bandwidth. Now we're going to look at comparisons a little bit. So basically, some of the most common ones are series elastic actuator. We also have the conventional actuator, but generally you're going to get into that. One of the newer actuators that are becoming more prominent are the quasi-direct drive actuator. And this has a large torque motor and small gear ratio in comparison to the SEA, which uses a small torque motor, has a large gear ratio, and also has a spring. So the QDD gets rid of that. And here we can see how the systems line up. The backdrivability of the QDD is high, also its bandwidth and its weight is low. And as we said before, those are important components when we're looking at the best actuator for a robotic system. These are the parameters that we inputted into Simulink when we were trying to do our analysis to see how they compare really. Now here we have a bandwidth model. So here you can see we have the PID controller. We also have the different transfer functions here and the gear ratio. We have the scopes which we can read the outputs from as well. The PID values can be changed to tweak how the system responds. Here we have the analysis from the bandwidth test for the QDD. You can see that it had a frequency of about 107. That is high and that is pretty good. When we compare it to the SEA, which has a very low frequency of about 8, you can see how impressive the QDD is. Here we have the backdrivability model. We have the step functions and the transfer functions. We have gains as well. And again, we can read the output through the scope. Here we have a comparison between backdrivability. And as we can see, that a low backdrivability is good. That is what we're looking for. Well, a low value. So in this case, that how the QDD has a value of 1.9. That is very good as compared to the value of 12.1 from the SEA. Now, a bit about what I've learned during this class. This class has been very informative. I barely knew anything about soft robotics coming into this class. I've learned a lot. I've learned its applications, especially in the biomedical industry, how it can be used to help so many people. Um, I've been exposed to MATLAB and Simulink as well, which I think can be, a great benefit moving forward. Thank you for your time. That's the end of this presentation.